Circuits are made up of three things. Whenever we are talking about circuits, we are actually talking about three things. First, there has to be power source. So there has to be a power supply. This is referred to as the voltage. Actually, there has to be a voltage because power is energy, rate of energy. Voltage gives us energy per coulomb, so this is referred to the battery. Next one is device to check output. It could be anything that can show us some sort of an interesting way to check an output. It could be a bulb which shows us that when the current passes through the bulb it glows. It could be a calling bell or anything, any device that helps us to check the output. Something is being output. And there has to be an enclosed loop. If there is no enclosed loop, there is a beginning and there is an end. Without that, there is no circuit. Let's talk about that one by one. First of all, the symbol of circuits. The power supply or the source, the battery, actually the battery is given by these symbols, long line and a small line, and this is it. This means some sort of a source of voltage. So this refers to potential difference. Now the next one, the output device can be many things. The most common is a bulb, given like this. This refers to as a bulb. It could also be something that gives an output is a voltmeter, a meter to measure voltage, like this. This is called a voltmeter. It could be an ammeter, meter to measure the current, ammeter. It could be a resistor, a device that actually has a number on it, 3 ohm, 2 ohm, 1 ohm, and it actually can be checked that actually the current before it entered the resistor and after it entered has actually changed. So this is a fixed resistor. So that's about it. These are the symbols used in a circuit, and when we talk about enclosed loop, we are actually talking about wires like this, which are all connected together. We're talking about wires actually in a loop of wires. So let's talk about a basic circuit. So the basic circuit is, this is the power supply, this is the voltage. So here now I'm using the loop, and this is the output check using a bulb. I'm using a bulb here, and all the way it is enclosed. Now this long line refers to the positive, short line refers to the negative. That's the symbol. Now when we talk about current, the flow of current is actually in the opposite direction of the flow of electron. Electrons actually flow in this direction. So this is something that needs to be remembered. Currents flow in the opposite direction of electron flow. So if electron flow in one direction, current would flow in the other direction. So the current would always flow from plus to minus. That's opposite of flow of electrons. So it would flow in this direction, and as the current flows, of course current is charges passing through time, every second, amount of charge passing every second. So this current would flow, and as it goes through here, the charge would give electric energy, which is converted to light energy, and it would glow, and you'll get some sort of an output, and then it would pass on and it would complete the loop. Unless there is a loop, there would be no circuit. Now why is that? Because the potential difference is the thing that forces this thing. It is important that this electric current flows through the bulb. Unless it flows through the bulb will not glow. You will not be able to check the output. But what makes this current flow? It is the potential difference. Potential difference is, you can think of it as a distance. If you carry a ball, a huge ball, up a tree and drop it, the ball is going to keep falling until it hits the ground. It is that distance that makes it fall. So the potential difference actually is like some sort of a push. It gives some sort of a force, also called an electromotive force from the battery. It pushes the circuit, pushes the current, all the charges, and makes it come back all the way through. So this is the potential difference that is very, very important. Now when we talk about circuits, we are actually talking about two types of circuits. One can be called about series. So series connection is the most basic. Suppose you take a wire, you take a source of current, a source of voltage, gives the push, and you connect certain things. You connect this bulb, you connect another bulb, and complete the loop. Definition of otherwise it won't be a circuit. Yeah. Now the current flows in this direction, opposite to the flow of electrons. So now these two are connected one after the other. This is a circuit. Everything in the household, usually with a multiple extension cord, you just put one after the other after. They're connected in series. So a disadvantage in series is that if there is a disconnection in anywhere, if there is a breakup in the loop, both of this output would stop working. So when you see in the lights, people decorate the houses before wedding or something, so you will see that if there is a cut in one of the wire, the entire building would stop glowing, the light would stop glowing. So that's a problem in series. So one thing to remember in series is that here, when you talk about voltage, if you want to find the voltage at any point, suppose you connect a voltmeter here, or a voltmeter here, a voltmeter here, total voltage equals to all the voltages put together, V1 plus V2 plus V3 plus V4, everything. Total voltage is this. And when we talk about resistance, total resistance is again R1 plus, pretty straightforward, R1 plus R2. That's series. So this is how we do that. Now the next one, parallel. This is more helpful because here what you do in parallel connection, what you do in parallel connection is that you take this potential difference and you connect this bulb and you make a loop, so the current is flowing like that. Then you take another wire and you connect it like this. So now they're parallel. The word is used literally as in geometry. So what happens here, if there is a connection loss here, if there is a something happens here, this bulb will glow. So what happens in the wedding, the light decoration that they use there, you will always see that they don't use the series, because if you just one of the bulb is fused, the entire light system would just stop working because they're all connected in series. But rather they're connected in parallel. You will see there are 2 or 3 lines in parallel, meaning if one of the light doesn't work, current will flow through here. A loop is connected, a complete loop is working, and the circuit is not broken. So that's why parallel connection is preferred in this type of activity. So now here in parallel, the current would be the total. So if you have a current here, it would be equal to all the current added together. So it would be like I1 plus I2. Current here is the total current, and the resistance would actually be the reciprocal. 1 by R is going to be 1 by R1 plus 1 by R2. Of course it can be many types. So this is the total. So these two things needs to be remembered.